Hello students, welcome back to my channel PositCon. Today's ray optics third. The first video was based on that what light is. Second and the representation of light obviously. Second video was how to make the images with the help of ray diagram in plane mirror if the two mirrors are at an angle theta. Many cases I have discussed with you all. Dear student, today's topic is a spherical mirror. We have to talk about the spherical mirror and how to spherical mirror, right? Today's topic is a spherical mirror and how you can create the images using the spherical mirror. How you can you predict the image in the case of a spherical mirror? Dear students, the two type of spherical mirrors we have to discuss. One is a convex and there is a concave. Either be the convex or concave, the spherical, why it is called a spherical mirror? They are, both are either be the convex or be the concave mirror, they are the part of a sphere, right? You can cut from this, you can take a cross section of that. Let you cut down the sphere from this portion, then you will get this kind of cross section, and the right hand is silver. This is undoubtedly it is a convex mirror. If you take this one cross section, it will be like such, and again the right side is silver, or the second side, the rear side is silver. This is the concave mirror. Dear students, I said that spherical mirror are the part of a sphere. Then the center of that sphere is the center of curvature. This is this, right? If you imagine the complete sphere, it will be like this. This is the center and this is the radii. So the center of that sphere, of which this is the part, is the center of curvature of this convex mirror, and the radii of that sphere is the radii of curvature of this convex mirror. In similar way, it is this. If you imagine the complete sphere, it is so, and the center will lie in this direction, and this is the radii of curvature, right? So dear student, spherical mirror are the part of sphere, and center of that sphere, of which they are the part, is called to be the center of curvature, and radii of that sphere is called to be the radii of curvature. Now dear students, sometimes we are a bit confused that a bigger mirror has the bigger focal or radii of curvature. A small mirror has a small radii of curvature. No, it is not that. Look here, very interesting fact I am telling you. Dear students, in this sphere, you can take this cross section or this cross section. If you consider this cross section, it is this, right? And rear side again, I have silver. And if you consider this cross section, this is, and again rear side silver. Now dear student, these are the part of same sphere. So they have the center of curvature like so, and radii of curvature will be the same. They have the same center of curvature and radii of curvature because they are the part of same sphere. In the similar way, in the right hand side, you can take the cross section that will give you the concave mirror. Now, dear student, what is the difference between them? They have the same radii of curvature, and you know focal length f is equal to r by 2. If the radii of curvature is same, they possess the same focal length. Now, this size is said to be the aperture. These are yet, despite they are having the same focal length, same radii of curvature, but this is having a small aperture and this is a big aperture. And dear student, the position of image depends on the focal length or radii of curvature. It does not depend on the size of the mirror, whether it is a bigger or smaller, whether aperture is bigger or smaller. The bigger or smaller aperture can decide the intensity of the image that has been created. If a bigger image, a bigger mirror, and it will accommodate more light rays, and so the image created will be more intense, whereas the smaller mirror will have a low aperture, it will contain less light rays. So the image created by this mirror might be the less intense. Now, dear student, it is all that how the mirrors can be made. The two mirrors, one is a convex mirror, just I have discussed with you all. This is said to be the convex mirror. This is said to be the concave mirror. Dear students, this is actually converging mirror, right? It converges the rays. It tries to focus the rays incidenting on it after the reflection. And this is the diverging mirror. Remember these basic facts. And this is converging mirror. Now question is that, dear students, can you predict the image made by either the convex or concave mirror if position of the object is keep changing continuously? Then let's talk. So today's topic begins with making the image by spherical mirror. Number one, first we are considering by concave mirror. Dear student, this is your concave mirror, right? Therefore, some basic rules that you have to remember. Dear student, this is the mirror. The geometrical center of the mirror is said to be the pole. In general, in easy language, you can say that the center of this mirror is said to be the pole. And this is the center of curvature. This is radius of curvature, right? So, the line joining center of curvature and pole is said to be the optical axis. Dear student, in order to make the image by any spherical mirror, whether it will be convex or concave, there are some basic rules. First, the rays incidenting parallel to the optical axis after the reflection from the mirror passes through the focus. Second, the rays passing through the center of curvature after the reflection return back to the same path. And the rays passing through the focus after the reflection passes parallel to the optical axis. These three are the basic rules. First is, this is the center of curvature. Actually, F is equal to R by 2. Just after that, we will solve that. This is the focal point, and this distance is said to be distance between focus and optical center is said to be the focal length, right? And F is equal to R by 2. That mathematically we will prove just after this article. Now, dear student, what I said, that rays passing through parallel to the optical axis after the reflection from the lens pass through the focus. Second is, the rays passing through center of curvature, after the reflection they will return back and follow the same path. Why it is? Actually, dear students, every spherical mirror, whether it is a convex or concave, they are the part of the sphere. This is the center of the sphere. And any ray meet this plane, meet the periphery, the circumference of the sphere from the center, right? All these are the normals, 90 degree, you know. Any line drawn from center to the sphere to the surface of sphere is a 90 degree. So it is a part of sphere, and see, center of curvature is the center of that sphere. So any ray from this, it is all 90 degree, right? And that is why the ray incidenting on it, it is normal, so will be reflected back, right? And third one is the ray passing through the focus after the reflection becomes parallel to the optical axis. These are the basic properties that we will use while describing the image formation. Dear students, let's talk one by one. First one is, this is your mirror. I'm considering concave mirror. This is pole. This is optical axis. This is center of curvature. And this is focal. Focus point is just at the mid of center of curvature and pole of the mirror. Dear students, if the object is kept at infinity, the rays coming from the infinity parallel to the optical axis after the reflection from the mirror passes through the focus. This is a basic concept, that the rays incidenting parallel to the optical axis after the reflection from the mirror will pass through the focus, right? Now, dear students, this is the rays parallel to the optical axis passes through the focus. But what happened? Look here, I'm taking a very interesting concept, that this time rays are not parallel to optical axis, but the rays parallel to each other, but not parallel to the optical axis. Now, where will they meet, right? Where will they intersect? Really, they intersect at the focal plane, at a point in the focal plane. Here they will intersect, right? Let it escape. If the rays which are not parallel to the optical axis, but many rays parallel to each other after the reflection from the mirror, they will meet, they will intersect to each other in the focal plane. Focal plane is what? A plane which passes through the focus and perpendicular to the optical axis. A plane which passes through the focus and perpendicular to the optical axis is said to be the focal plane. Dear students, so when the object is at infinity, the rays incidenting on the mirror will be parallel to each other, parallel to optical axis, you can consider. So either the image will be made at the focus, because you know the rays incidenting parallel to the optical axis after the reflection from the mirror will intersect at the focus. So either the image will be made at the focus or image will be made at the focal plane. Focal plane is what? If the object is too far, then rays incidenting on the mirror coming from the object, might be they are not parallel to optical axis, but they will be parallel to each other, and after the reflection from the mirror, they will meet somewhere in the focal plane, right? Now, dear students, let's move further. This is C, this is F. Now, we have considered an object A, B between infinite and center of curvature. Now we are moving from left to right, right? This time object is kept between infinite and center of curvature. How the image you can create? Dear student, a ray, very simply a ray parallel to the optical axis I have considered. After the reflection from the mirror, it will pass through the focus, this way, right? Simply, second ray I am considering passing through the center of curvature, and after the reflection it will return back and follow the same path. These two rays intersect here, right? Now, dear student, this is AB, this is A dash, B dash. Look here. Images, these rays, you have got the image, you created the image. When the rays were actually, the rays are actually intersecting to each other, then you have got the image. So, the image of AB is A dash, B dash. Now, dear students, the image is inverted. So, the rays are actually interfering, actually intersecting to each other. So, the image is a real, right? And it is AB. This is A dash B dash. Image is real and inverted, and also smaller than the object. So it is a diminished. Image is real because the rays are intersecting rare, right? This is not a virtual intersection. We will talk later on. Many cases in which you will see that image is made. Either you have to just move your ray diagram back or forward, only then you can create the image. That is a virtual, right? Here the rays are intersecting rarely. That is why the image created is real, inverted and diminished. Let's move further. Next is, dear students, again, this is the focus, this is the center of curvature. This time I am considering the object AB is kept at the center of curvature. We are moving from left to right, right? First, we consider when the object was at infinite, then when the object was existing between infinite and center of curvature, and now it is at center of curvature. One ray I have considered parallel to the optical axis, that will pass through the focus after the reflection. Another ray that it passes through the focus, and after the reflection it becomes parallel to the optical axis. Actually, if geometrically if you will draw using the instruments, then it will like so. Now the image will be made at the same point. If the object is kept at the center of curvature, the image is that. Image is just inverted at that point. It is a real inverted, and the height of image is equal to the height of object. The size of image is equal to the size of object. So when the object is kept at the center of curvature, image will be created at the center of curvature, inverted, and the height of image or the size of image will be equal to the size of object, right? It is real, inverted and equal in size to the object. Now dear students, let's move further. Third case is what? Now let's move. This is what? Again it is your concave mirror. This is the concave mirror. This is pole. This is focal length. This is center of curvature. Up to the center of curvature we came. Now we are just assuming an object between focus and center of curvature, right? A ray I am considering like this, parallel to the optical axis, and that will pass after the reflection from the mirror, that will pass to the, this is one ray I have considered that it is incidenting parallel to the optical axis, and after the reflection, no doubt it will pass through the center of curvature. Now dear student, second ray, from where you will consider the second ray? Second ray, let it passes through the focus in this way, and after the reflection, the ray passing through the focus after the reflection becomes parallel to the optical axis in this way. Now look here. Dear student, this time again the rays are actually intersecting. The reflected rays are actually intersecting. That is why the image will be real, right? And it is inverted. And this time it is bigger than the object. The size of image is bigger than the size of object. Now let's move further. Next case, undoubtedly it will be when the object is kept at the focus. In that case, image will be made at infinity. How? This is your focus. This is your center of curvature. Let the object is kept like this. In this case, what happens, dear students? A ray parallel to the optical axis you can consider like this. After the reflection from the mirror, it will pass through the focus. Same. A ray passing through the center of curvature you can take like this. Now, dear students, look here. These rays are parallel to each other. They never will intersect to each other. Either you move forward or just draw it backward, right? So the image will be made at infinite, right? The last case is important for the convex mirror. Concave mirror, sorry. This is the mirror. This is the geometrical center of pole, right? This is the focal length, least but not last, is the center of curvature. Now, dear student, last case is what happens when the object is kept between focus and pole. This is the last case of concave mirror when the object is kept between the focus and plane. Can you predict where actually the image will be formed? Let's talk. Dear students, nothing in physics we have to mug up. We just have to apply the basic concepts. Basic concept is what? You can take a ray parallel to the optical axis. After the reflection, you know, this ray passes through the focus in this way. This way, one ray you got. Let's take another one. Another ray I am considering from center of curvature. Yeah. If you move further, they are diverging to each other. There is no hope, no opportunity to meet to each other. They are not going to interfere to each other. They are not going to intersect to each other. So what is you are left with? Just move them back, right? These dotted lines are the virtual lines. They are not actually existing. It is that you are just drawing them to let them interfere, to let them intersect, right? In this case, look here. This is A dash, B dash. In this case, rear to the mirror, the rays are virtually predicted, virtually made, right? So, AB is the object. This is virtual because these rays do not intersect to each other really. So, in order to intersect them, you have to move back, right? Now, dear students, this is in this way. So the image is a bigger, virtual, and upright, erect. Dear students, in the case of concave mirror, this is the concave mirror, this is the geometrical center, this is the it is a part of this sphere. So this is the focal and this is the center of curvature. Now, dear students, look here. Let the object is in this way. A ray parallel to the optical axis after the reflection appears to come from the focus in this way, right? Another ray, let it is moving towards center of curvature, right? A ray moving appear to go towards center of curvature After the reflection, we return back and follow the same path. These two rays are virtually meeting here, right? Now, dear students, image is upright, and these two rays intersect to each other virtually. So, image is virtual, upright, and it is diminished, is smaller in size than the object. Dear students, I think this is enough for today. I tried my best to let you understand. Next topic undoubtedly will be based on the derivations of formula F equals to R by 2, mirror formula, and some questions regarding to that, and a lot we will talk. Magnification, whether how much is image is magnified. Least but not last, I hope you people are following my lecture. And if you think that my lectures are going to be beneficial to you, then please and please request you, please share, subscribe, comment, and put the bell icon so that you can be notified about my next video. Soon we'll meet in the next video. Bye-bye.